Welcome to today's webinar on Rockin Simulation, 2 hearts, 1 passion. Today we want to show you how you can simulate a guitar and probably a few things around it, but we will not only focus on the simulation part, we will also go on the live side and show you how guitars that have been designed with SOLIDWORKS sound and how you can play them. Therefore, I want to welcome my colleague Wolfgang Müller from Bechtle PLM.
Hello from my side.
And I'm Axel Weidmann. I'm Simulia's partner sales manager at Dassault Systems, and I will guide you a little bit through this webinar today, while Wolfgang will do the main part. Later on, we will also welcome my colleague Kilian, who will join Wolfgang in playing guitar. First of all, I want to show you a little bit what we are capable of doing, because Dassault Systems is not only simulation and not only modeling. We are hosting the whole range of product development within our products. Therefore, we also have the possibility, for example, of Delmia, of our brand Delmia, where we offer manufacturing solutions. But today, we want to focus on 2 of our solutions. First of all, the SOLIDWORKS solution, and the second is the Simulia solutions that we want to show you. If we want to have a look at our simulation topics, we offer a broad range of different simulation possibilities, coming from structural simulation, going to electromagnetics, going to plastics injection simulation, and also PCB simulation and thermal simulations with fluid flow simulation. Today, we will mainly focus on structural simulation, on the electromagnetic simulation, but we will also look at fluid flow together with thermal simulation. But for now, this is everything for me, and I want to hand over to Wolfgang, who will now cover the main part with the simulation topics.
Thank you, Axel. So, yes, thank you, Axel, for introducing me and for having me here. And so I would like to talk about some things, how to combine 2 hearts into 1 passion. That means to be a developer of products and being a musician, and how to have both worlds in 1 theme. My profession for the daily work is at Bechtle PLM. I'm sales specialist for simulations, and Bechtle PLM for this moment is at Germany, Switzerland, and Austria. And we are doing several things about SOLIDWORKS and all the applications. And my whole day life is in the simulation. From my education, I'm a machine building engineer. And so this all what I introduced to you today starts several years before. Let's have a look to the agenda for today. We will see the cut model of an electric guitar that I did a few years before, a bit of visualization of this, and then I come up with an idea what happens if I tune my guitar. I know how to do this in real world, but is there a way to simulate this? And next thing is, what about a dynamic study? When I strum some chords on the guitar, of course, I know how to do this. But what about having this in a simulation? This could be interesting. And the next thing is, if it's an electric guitar, the tone and the sound is produced through a pickup, a coil. And of course, I can model this, I can visualize this, and of course, I can have some simulation of the magnetic field. And let's have a look on a tiny aspect, maybe with a huge impact on what you play on your guitar. And from this, when I get the sound out of my guitar, it gets into an amp. And there's a short story about a custom-made amp. And this is an all-tube amp, and some of you will know if you have a good temperature on your amp, on your all-tube amp after the gig, you should cool it down before you transport or kick it, maybe, no matter what you want to do. And so a drop test could be a good thing to have in a simulation. And because of the temperature inside the tubes, could be interesting how this distributes through the amp. And so you know where to put your fingers and, of course, where not. And finally, little thing is when the speaker works and the air gets in motion. So this is what needs to happen so that you hear something. And let's have a look to the air motion when the speaker works. So be excited, cool down, lift your feet and enjoy the show. It all started, let's say, 20 years before, when I built in SOLIDWORKS my model Fender Stratocaster guitar in SOLIDWORKS as a 3D model and in a lot of details. And I'll show you the model in SOLIDWORKS. Just a second. So what we see here is real SOLIDWORKS in the version 2025. And the 3D model of this guitar, yeah, what you see here is CAD modeling 20 years ago and still the current state of having a Stratocaster in a lot of details on your screen. To any little detail if you want to see with the strings, with the pickups and everything you could have a look to. So this finally was the start of what my thoughts taught me to do. And let's switch over to what I did with this. What, of course, is very nice to do is to have a visualization of the guitar, of the whole guitar, finding the best position on the screen and have some details and just for the fun of it. But let's get serious. What happens when I tune the strings? So finally, you have a certain string and the right tune you see left down in the table on your string, a certain string, and the frequency you should go to. And this is the bass frequency, no harmonics on top. So when you know your tone A is 440, well tempered, it's 110 in the ground frequency or the bass frequency you should address in this simulation, because this is the bass of it. And so you have the string. Let's talk about the A string. And you have a certain length, and this is the start of tuning that string. And then you turn your tuners, and so the length of your guitar, not of the guitar, of the string, could change. This is the way to calculate this. But the tension and the stress inside the string, this is an external load to the string. This has an impact onto the string to optimize the length or the inner tension to get the right frequency to have a well-tuned guitar. And what I used for this was SOLIDWORKS simulation and the design study or the parametric optimization to get the optimum to find the real change to the string and to get the certain frequency of this string. So it's good to know. Maybe we see in future, and I have an automatic string tune system. It exists on the market, but not from me. So maybe this is the base for this. Next thought, what I had, what can I do with a guitar? I had this in the agenda, you remember. And what happens if I strum the guitar, maybe just a chord or the strings by itself, and you see what happens. And from the simulation aspect, this is dynamic, this is linear dynamic here, just to have displacement on a string in a row, one after another, and to see how they swing in their tuned situation. This is also be done with a desktop solution integrated in SOLIDWORKS. And this is just a step to go further on. What happens if I tune my guitar and if I strum some accords? Then I want to hear this, and to hear some sounds of the guitar, I need a pickup. Maybe you know this from your guitar. It could be a single coil or a humbucker. And in the history of the single coils, on the left down corner, you see 6,000 to 8,000 turns. Could be on this. When you go back in history of producing pickups, nobody knows how your special pickup would be produced, because they didn't count very well the turns. Today, in industrial production of this, this is exactly to know and exactly to reproduce. And so there is range 6,000 to 8,000 turns, and a certain wire diameter, and an impedance course of this. And the copper-farben area, this is the wire in the turns, and the rods here in the magnetic poles, these are magnets. And the combination of this, when the string is moving in that area, then there is a change in the magnetic field, and this is amplified and turned into an electrical signal, and this goes to the amplifier. And what happens here is an electromagnetic effect. So what did I do? I did do a magnetic study with CST Studio Suite. Here we are in the live application. You see the same model, and again, it's real 3D. And what I designed in SOLIDWORKS, CAD is the base of all my thoughts, how to simulate several things. I can have this here in CST Studio, and I define the permanent magnets, and I can define the direction, how it works, coercivity, and the strength of the magnetic field. So there are several magnets to use, and the more distorted sound you want, the higher should be the impedance, and you get more power and more distorted sounds if you like to. And let's get to some results and tiny little effect what could happen. So what I compared is if you use nickel steel string or pure steel strings on the lower left side. And what happens is to the magnetic energy density, you have a few percent difference in what happens when you play in real time with a different kind of strings. You will hear this. That is more output or less output, maybe a smoother tone, or maybe less distorted at a certain configuration on your amp. And on the right side, you see this here on the first string, how the field from the nickel steel string is compared to the pure steel string. To any details, we could go to the legend and to the numbers. But maybe you want to ask this in the question part after the webinar. So we could talk about this. And once the tone leaves your guitar through a cable. We don't talk about the cable today, but then it comes into an amplifier. And what I introduce you here is a custom made. It's called a Felleretta Chuck 50. It's custom made for me, so it's a pure all-tube amp. And what I wanted to have was very light all-tube amp, 50 watt, 2-channel, 18 kilo, very comfortable, and very few control, gain, volume, both 2 times, tone, presence. That's it, and ready to rock and roll. And what happens to an amplifier, maybe in real life? Of course, you need some details. Again, for the fun of it, more details, the chassis, the trafo, the potentiometers, the switches, the speaker, and the valves. You can have any details made in SOLIDWORKS as the base to go further on with your simulations. And one simulation, and you know, as we know, well-tempered tube amp, you should not kick or drop down. So what happens with a drop down to make it as safe as possible, because sometimes you cannot avoid that it gets dropped. And on the left side, you see, and there's a scaled factor of 100. So this is not what happened in real time to that amp. You see in that area, fixed with the screws and the bolts, that is the most of the stresses up here. And you see in an explicit dynamic study what happens to the amp. Maybe you're interested in how I did it. Just a few words. I took this amp from SOLIDWORKS model directly to the 3D Experience platform. And this model here, of course, I got a mesh and I have the parts inside, some tubes and very small details I removed for an explicit dynamic study. And there's gravity, and for an impact from the down or the bottom of the amp, there's a force with a certain amplitude. And this is how to make your simulation. And let's have a short view onto the von Mises stresses. Here is an animation of the stresses to the speaker, and this is scaled to see what happens. And in the background, you see that also some movement happens to the trafo. Now, when I know that it's possible to do this on the platform with an explicit dynamic study, you see, and you see this in the upper corners here, and the movement of the speaker and the fixture. And you see the maximum stresses here. And on the right picture with the vectors, you see the acceleration. And the best acceleration, no wonder, you see on the chassis where this heavy, I guess 2.5 kilograms trafo, pulls down the chassis from the fixture through, bumping onto the ground. And this is the vector seen here. And this acceleration should be fixed with your choice of fixing the chassis into the housing of the whole amp. And of course, we can have this not only in pictures and animations, we can have the real diagrams to check maybe version 1 to version 2, version 3, what is the best one finally to find an optimum. And why do we simulate? We find the optimum before we build something, and we know after doing several studies, we have the optimum, and then we build it once and we have a very good product in the end. So how does an amplifier work? Let's look into the inside. Lots of cable, lots of tubes, and funny things, and done by a known technician, and building this for producing the sound. And in an all tube amp, you have high temperatures. We talked about a little bit earlier with the agenda, and I throw this into SOLIDWORKS flow simulation. Why? Because I guess nobody, not anyone is aware what happens inside a tube. So when you bring this in a good mode to work, then it could happen. It has far more than 200 degrees Celsius, and you should know where goes the temperature, and where you may touch the amplifier and where not. So these are two certain areas for the temperature. You can see on the left side, on the right side, down below, inside the valve and inside the electronics. And you can have this, of course, also on the chassis. So not touching the inner electric and electronic parts. Anybody knows not to do this. But on the sheet metal, maybe there's a chance to have your hands on, and you see where you may do this and where not. Let's have a short look into the application where I did this. So now we are in SOLIDWORKS CID, and we have this amplifier, we have the whole model, the housing, we have the speaker, and the control plate with a double axis potentiometers and some switches, and the tubes on the inner side. And what I showed you on the slides. Das ist einfach diese schöne Verzögerung. Ich habe es jetzt mal so stehen lassen. What I show you on the slides is the following. This is the chassis, the speaker, and the electric, and the SOLIDWORKS flow simulation. And we can have the ISO surfaces. And what you see here is the zone where you find temperatures from 60 degrees and higher. And the next thing is the area where you find 150 degrees Celsius inside your valves. And this is a lot of temperature. It's isolated, so not too much risk to get there. But you should know about what happens in your tubes, and the temperature could be in your interest. So let's hand over to the next thing, what I did. So when I know the amp is working, then the final, or maybe the most interesting thing, is to hear any sound. Unfortunately, I cannot simulate the sound, but what I can simulate, and maybe what is with a real impact on designing the perfect housing, to see how the air is moving. At an example, 500 Hertz, in a lower frequency when I play guitar, and where is the air going? What does it look like? And let's have a short idea. the relative pressure in the room. And you see there's a very interesting distribution of what happens with the air, just seeing the pressure. And having this in 2D, I was eager to see what will it look like in 3D. And on the right side, you see how the pressure is really pressed through the openings of the housing. And this is how your speaker moves the air, what brings the waves, finally make you hear the sound. I show you something. Let's check what happens when I move the speaker. And this is maybe one little secret on the volume that the speaker moves. And this is just a formula. Done inside the solution, where you can calculate how, like a synodial form, the air is moved by the speaker. And for today, I would say this is a lot of idea how to combine making music and having this for the real world. And I have some models of real guitars, and there is one guy doing Mr. Thomas Stricker doing carbon fiber guitars. Very interesting, and finally, absolutely ignoring moisture in the air when you go overseas or whatever, and much better than wood, and very lightweight guitars. Of course, the model I showed you before was done by me, but the real producer of this original instruments is Fender Musical Instruments, and they also work with SOLIDWORKS, I think for a good reason. Maybe you also know Paul Reed Smith. If you do not know, have a look to this and grab one, check it out, and maybe you feel again what is possible with a good CAD system. And one thing maybe you have not heard before, Lava Drops. It's a cool guy from Lithuania, and he designs guitars from very special material and very good sounding, very well playable, and on the 3D Experience platform. And this is very innovative, and he's very satisfied from any point where he wants to. He just switches onto the platform, and he can work on his designs and communicate with the luthiers and the handicrafters to model such a beautiful thing. If you don't know this, maybe you are interested to see this a bit closer and maybe to hear this. So a bit later on, we'll show you in a live session how to play a lava drop guitar. So thank you for your attention.
Wolfgang, thank you very much for your great presentation. As Wolfgang will now prepare for the guitar session, we hand over to our colleague Sean Farrell, who will tell us something about additively designed and additively printed guitars. In the meantime, if you have any questions, please type them into the Q&A session of Zoom, and we will answer them afterwards, as we are running a little bit out of time. This said, Sean, over to you.
Hello, everyone. Thank you for joining us today for this webinar. My name is Sean Farrell. I'm based at the Boston office, and I'm part of the 3D Experience Lab group, which is the innovation arm and startup accelerator for Dassault System. I'm really excited to be presenting today because I'm a passionate guitar player, and So for me, this is a really exciting project. So let's go ahead and dive in. I'm going to talk a little bit about, the design of guitars, and especially the design of like these interesting latticed guitars and how they can be 3D printed. So on the left-hand side, I have a guitar body, very, very popular guitar design called based on the Fender Telecaster model, which you've probably seen many times before. And so this guitar body was designed in SOLIDWORKS, 3D Experience SOLIDWORKS. I brought it into XDesign, which is a web-based design application. So you can access it from PC, Mac, iPad, or even your phone. Um, and so in XDesign, I made various modifications. Most importantly, this cutout area here. This cutout area is where the latticed section will be integrated. And so after I designed the cutout and figured out where I want the latticed portion to be, I brought the model into an application called CATIA Lattice Designer. So it's a CATIA app, and that application allowed me to easily and efficiently produce this latticed design here. In a conventional parametric, program such as XDesign or SolidWorks, this would take a very, very long time or be impossible to do. In CATIA Lattice Designer, I was able to do this in a matter of seconds, probably less than a minute. And of course, I spent some time evaluating different lattice designs, different geometries, different thicknesses of the lattice, and then, played around to get the ideal weight of the body that I wanted to achieve. And once that happened, I saved a design and then moved forward. So basically, this is my layout and my dashboard for file management. This is all my files in my collaborative space. I have my bookmark editor, which allowed me to easily organize all my files that I wanted to work on for this specific project in one convenient place. Um, I had the help of a colleague, Sebastian Rosell, based in at the headquarters in Belize, design a guitar stand for me in X Generative Design, which is a CATIA app. This guitar stand was actually milled on their CNC router. It has a really nice hexagonal pattern. And then, as you can see here, I have the full assembly of the guitar. So this is the body. This is a different version that was printed out. As you can see, the lattice design is a bit different than this one here. So, but after the body is designed, you can bring everything into a full assembly. So this has the strings, as you can see, the pickups, the bridge component, the volume and tone knobs. Got the 3D Experience Lab engraved logo there, and the guitar tuners. So, obviously when simulating, the entire instrument as a whole is ideal. You can simulate, the electromagnetics, the acoustics. You can simulate, of course, how the strings will create stresses here because of the string tension when it's all tuned up. So it's really interesting and wonderful to be able to bring all the components into one overall assembly. Very cool, especially to see how it will look all together when everything is assembled. Um, so yeah, and then moving on to 3D printing, um, this little time lapse shows a miniature version, a scaled down version of this lattice design being printed, just using FDM technology. This video also shows 3D printing using FDM. This was actually on a Gigabot printer, so it was a large format printer. This is printing an entire full scale body all at once. This actually took a little over a day to print. Fortunately, there were no issues with the print. But yeah, this one was interesting because the material used here was actually PET, so the same plastic that you'll find in Poland Spring water bottles, for example. So that can open up a lot of interesting opportunities to print from recycled plastics. A major issue in the instrument, industry, especially with guitars, is they use a lot of wood to produce these instruments. And I know a lot of companies have been able to, sustainably source their wood. However, it's still a concern as we move forward. Um, and so coming up with sustainable methods to produce the instruments and sustainable materials as well is really important and intriguing. So being able to print from recycled plastics could be very interesting. This is a little video of another concept that was produced using CATIA X Generative Design. Again, it's a visual scripting um, program. It's very, very interesting to work with. Different than the conventional parametric design methods, but you can do some pretty incredible things that couldn't be done in traditional software programs. We didn't print this one, but I just wanted to show it because it's a really cool design. And then this image here shows a slicer software, specifically from Formlabs. Um, preparing the body to be printed. It had to be, this particular version needed to be printed because of the size of the print bed wasn't large enough, so it needed to be sectioned in half. And that's why, as you can see here, some um, if I can hide this component, um, we were experimenting with different methods to join the two halves together without creating unwanted stresses here, um, things like that. But we ended up ultimately printing this guitar here on one SLA printer, so it printed as one body, which is definitely ideal. So moving on, there's a brand from Dassault System called 3D Excite, which is a really has some great software programs for rendering and producing like technical illustrations, such as this one. So this is an app called X Highlight. So I brought the full assembly of the guitar in, and you can create little demos in the forms of videos or even like PDF documents. This is especially useful for like assembly guides. So, if I wanted to create an assembly guide on how to put this guitar together, I could do that in this software and create beautiful documentation to help people to provide instructions on how to assemble the guitar. One thing I should also mention is this guitar, because I'm sure some of you may have questions on that. The neck and all of the other components of the guitar were taken from a kit, from a guitar kit. The body was what we designed and printed, but subsequent projects we will definitely like mill the neck here, and which would be cool because then we could really make sure that we use sustainable wood and materials. And then of course the tone and volume knobs and the switch can all be, those can be milled on a Tormach CNC mill, for example. And then the pickups, we're not in the business of making pickups, so we can source those as we have for this example. Yeah, so moving forward with the X Highlight, you can do exploded views and show how everything comes together to create the final product. And so I sectioned it here to show the lattice, to kind of focus on the lattice design, and to show how CATIA Lattice Designer was used. And then one last point, we have manufacturing as a service, which is an app that you can use. You can simply just drag and drop your files right from your collaborative space or bookmark editor into this application, and it will connect you. So basically you choose what kind of manufacturing service you're interested in, either CNC milling, CNC routing, or 3D printing, for example. And yeah, it will connect you to vendors, vetted vendors from all around the world, who can manufacture for you, and you can get an instant quote. So it's comparable to something like Proto Labs or Xometry. But these are, vetted vendors, and you can, get an instant quote, which is really useful and was used for this project as well. So I simply just dragged and dropped that 3D XML file of the guitar body into this and got connected to some vendors instantaneously. So it was a huge time saver. And also there's another application called Part Supply, which has a really extensive catalog of standardized parts that you can drag and drop right into your assembly. So that can be very useful for projects like this as well. So thank you very much for watching this webinar, for tuning in, pun intended. The instrument industry is super interesting. It's actually, very, very old, but in recent years we've been seeing a lot of innovation in the industry. So it's really cool to be a part of that. And yeah, definitely stay tuned to see what other projects we put out. Thank you. Cheers.
Thank you very much, Sean, for this really interesting insight. Therefore, thank you very much for your attendance, and don't drop out now and join us for the live session of Guitar Play. Thank you very much.